Welcome to SOLIDWORKS Live Design, everyone. SOLIDWORKS Live Design is a series that we run here at SOLIDWORKS that is dedicated to the pursuit of learning from one another using the medium of live demo and exploration as we share our favorite software tips and tricks. So my name, as you can see here, is Sean O'Neill, and today we're joined by this guy, Noah Zeiff, not Kenny Martin Jr., by the way. Noah, you and I have known each other for, several years now, but just
Yeah,
over the next 60 seconds or so, can you tell us what you're all about and the primary topic of this episode of SOLIDWORKS Live Design?
definitely. Hey, Sean. Hey, everyone in the chat. Super excited to be here. For those I haven't met, I'm a tech guy here at SolidWorks, and I mainly work on our cloud-based design tools called the X apps. And when I'm not using them to 3D design for work, I'm using them to 3D print for fun. And this was a project where I got to combine those passions together. So today's episode is all about how I use them to make a 3D printed product I saw on TV, which I thought was super cool. I just had to have one. You've probably seen it before on social media or somewhere else. It's a fully 3D printed airless basketball. And Wilson introduced this last year during the NBA dunk contest, as we saw with Kenyon Martin. And this caused a whole lot of hype on all the interwebs and everywhere. And just 3 weeks ago, Wilson actually started selling a limited number of these basketballs. And they started selling them for the very small price of $2,500, which might be a little steep for a basketball, I'd say. But despite the price, they sold out in like 2 days,
Yeah.
which was absolutely wild. But what I thought was even more wild was the response from the maker community. So there have been tons of people now 3D designing and 3D printing their own versions of this basketball. And I just found that super inspiring. So I thought, I have the tools, I have SolidWorks, I have CATIA. Maybe I could give it a go myself.
I thought no less was going to come from you, Noah. So when I saw you were starting to get into this, which we'll talk about, I was not surprised. But when we talk about SolidWorks Live Design, and you guys who have been here before know, right, when it comes to SolidWorks Live Design, we're committed to getting to the good stuff, the in software content, the tips and tricks that I talked about earlier, as quickly as possible. But hey, Noah, before we do, can you tell us and this is something new we're doing this year, the three key takeaways for this episode? In other words, what are the three big things that our viewers are going to walk away with here today?
Absolutely. So our three main takeaways today are going to be one, how I designed the solid basketball fully on the cloud using SolidWorks X Design. The second takeaway is going to be how I added the pattern using another cloud tool called X Generative Design from CATIA. And the third key takeaway is going to be how I brought this thing to life, how I manufactured it using 3D printing.
Awesome. So I'm going to give you the inbound pass here. Do you like the basketball pun? I tried.
I love it.
All right, man. So let's get started. So we're going to spend about 5 to 6 minutes per takeaway. But let's get to your first takeaway, which you just mentioned, right? Designing the solid ball, designing the basketball here in X Design. But again, a lot of the stuff I'm sure you'll talk about is also applicable in SolidWorks. So yeah, let's take a look at this first key topic, this first key takeaway, and see what you had to show us here.
Let's do it. So here we are in X Design, again, our fully cloud-based modeling tool, so no download required. And this is a parametric modeling tool, which means it has a lot of overlap with SolidWorks, meaning, you have those extrudes, those revolves, those fillets, and many other familiar tools. Now, to use them to design this basketball, it honestly wasn't too crazy. This is a pretty simple shape. It's got a lot of symmetry to it. In fact, all I really had to do was model up this small portion of the ball and just mirror that over a bunch of times until I got the design I liked. So that was pretty simple from the outside, doesn't look like much. But if we pan around and look at how these pieces connected, how I tried to do that, it got a bit more complicated. And if you're watching this and you're kind of confused, you might be thinking, well, I've seen people 3D print this basketball. They always do it as one piece. And that's definitely true. I tried to challenge myself here and do it in pieces for two different reasons. The first was I wanted to see if I could print this basketball with absolutely no support. So I was using a flexible material to see if I could get this thing to bounce. And I was using a single extruder 3D printer, which meant all of my support material would have to be in the same material as my model. And if you have flexible support material and a flexible model material. Trying to break those away, it's like trying to pull together two rubber bands that have been glued together. They kind of just stretch apart. They don't break away. So that was the first post-processing step I tried to avoid. The second reason why I went this route was build volume. I wanted to make these files public, and so I wanted to see even if people with smaller 3D printers could split these parts up even further and print the largest basketball that they could, get it as close to the real thing as possible. So those are my two reasons why I printed in pieces. I also had constraints when it came to designing these interlocking mechanisms.
Yeah,
The
this
first
seems very
was,
interesting.
yeah, the first constraint was I wanted no glue. I didn't want to get messy and have to, buy some really expensive, what is it, that crackle glue that is really good for 3D prints. I wanted to just make these snap together, make these fit together, as easy as possible. So that was the first constraint. The other constraint was all of these pieces, I needed to have a flat bottom surface so that it could stick to the build plate of my 3D printer really well and it wouldn't get knocked off. So for these orange pieces here, I made sure to have this flat bottom piece that could stick to the bed. Same for this one. And for these laces parts, I used these as the bottom faces. I could have printed on either side. There would have been an overhang in the middle here, but I made sure that that was a short enough distance so that my printer could bridge it without needing any additional supports. So that was really kind of a driving factor throughout this first takeaway. Having my manufacturing method in mind as I was designing this. In this case, 3D printing was my manufacturing method. So DFAM, design for additive manufacturing, was the biggest thing throughout this first takeaway.
Yeah, and this isn't the one in the thumbnail, right? This is like a standard basketball. You wanted to get to this one first, as you mentioned. I'm going to show this link as well. You kind of teased it. We'll show this throughout the episode, but solidworks.com/Noah. You mentioned printable copies of some of the models, but yeah, let's. I'll keep this up for now, but let's actually get to your second key takeaway, which Noah, we've mentioned it. It's very inclusive inside of the thumbnail and the marketing for this episode, and it's actually adding intricate patterns to your designs. I think this is one of the biggest takeaways, honestly, of this episode.
Definitely. So like you mentioned, Sean, I added all these patterns using a different application. It's also fully on the cloud, and it's called X Generative Design.
Okay.
And the great part about it is it's connected to the regular X apps like XDesign, XShape, and others. So I can take geometry straight from XDesign, like this pattern here, for example. Show it. So this was made fully in our parametric tool XDesign, and I could bring it right into X Generative Design through an app switch. So that's kind of the beauty of the platform, bringing all of these design tools together. And the reason why I'm doing this is because with this new app, X Generative Design, I have the ability to design algorithmically. And you'll see this is very different from typical parametric software like SOLIDWORKS or XDesign. Basically, I can add a design sequence, which is going to act as kind of our design manager, where we can house all of our features. And then I can do things like insert nodes, which are similar to features in SOLIDWORKS. And I can have this input node point to our surface.
Mm-hmm.
And then we can do cool things like add a triangulate node. And what this is going to do is it's going to split up this surface into triangles based on a length I specify. So I'm going to say 10 millimeters. And just like that, we have split our surface. And for any SOLIDWORKS users watching, you can imagine how long this would take to do in a regular parametric software, how many sketches, how many lines, how many constraints you would have to make. So
Yeah,
that's the
we aren't
beauty.
necessarily,
Yeah.
just to give like a few seconds of commentary. I know you aren't necessarily saying like don't use SolidWorks or only use this tool for your designs. You would never only use this tool for your designs, but for certain architectural applications, certain, as you see here, Voronoi patterns, certain very pattern-rich, intricate pattern type designs, as you've shown with over the, like we saw with Bowhead Corporation during our What's New launch, like those sort of intricate handle designs. in SolidWorks, you wouldn't be able to do this quickly, and again, this algorithmically. So it's actually it's an interesting way to design certain parts, certain sort of subsystems for sure. And yeah, these end parts can be put into SolidWorks models as well, which I think is really cool.
Yeah, that's a great point, Sean. It reminds me of, I'll shout out Darren Grosser from Go Engineer, because I attended his session at 3D Experience World, and he used this tool, and he says, you can do this in SolidWorks, but should you do it in SolidWorks?
It's a good question.
You
Yeah,
know?
it would take long. Yeah.
So that's the beauty of algorithmic design. And if I wanted to change this to 8 millimeters, you could see it updates pretty snappy. So like you mentioned, Sean, it's just a good enhancement for your regular parametric tools. But there are parametric nodes right here in X-generative design. So I can use the fill command, and I can fill all of those triangles I just made. I can also assemble them and bring them together as one mesh.
Huh.
And one of the other really cool things about algorithmic design is I can highlight sub-elements, which means I can highlight all of the faces, edges, and in this case, vertices of our geometry. So I'm going to take our geometry so far, put it into this sub-element. And now since I've highlighted all of the vertices, we can see just the vertices have been created.
Okay.
And now we can actually reference those to make our Voronoi pattern, what we've seen in the thumbnail. So I'm going to create a Voronoi node. This is similar to basically making like small hexagons at each one of these vertices.
Mm-hmm.
And I'm going to generate them on our initial input, which is that surface. So I'm going to say for our skin, that's going to be the original surface. And for these points, it's going to be all the vertices we just created.
Mm.
And now we have the beginnings of our pattern.
That's awesome. And it's following that same surface, which is like one of the hardest things to envision modeling. Like if you come from a lot of us do, like a sort of parametric way of doing things, a very ordered chronological way of, adding little shapes here and there and cutting away at them. It's a very simplistic sort of idea of what parametric modeling is. But yeah, that is super awesome and easy to kind of update as you kind of switch in and out of these modes. That's really cool.
Yeah, and like you said, it fits exactly to the geometry surface that we inputted. These aren't, all the same exact size hexagons. They're smart enough to realize, all right, we want to fill out the surface, as much of it as possible. So it's really handy there. And that was honestly really all I did to make this pattern. From here was a lot of thickening, a lot of Boolean, similar parametric tools that you can do inside of X-generative design. And I was left with my final design sequence, which looked a little something like this.
Okay.
So what I actually did was I made a negative of this pattern. And I subtracted it away from the solid spaces.
Oh, that's neat. Okay, so you actually did use the sort of initial state that we looked at as in a sort of Boolean, like you're saying, like a little like Boolean subtraction operation.
Exactly. My background is in parametric modeling, so I'm still trying to cling to that design methodology, even with this new complex, patterning software. So that's what I did. I cut this away from the original solid surfaces, and this is what I was left with. So these are all our patterned surfaces.
That is awesome. That's so cool. I had so much fun rendering this for the thumbnail of the episode, by the way. Like, it's just such a cool looking model. Plus one, everyone in the chat. I see a bunch of you making funny basketball puns as well. So I want to give you guys a shout out too in YouTube chat. So try to keep things tight, concise, and informative here, but still having fun. And once again, you guys, quick shout out to solidworks.com/Noah. After the episode, we still have more to go. One more key takeaway, which we'll get to in a moment. Feel free to ask questions to Noah. We'll give another shout out to this at the end, how to do that. And download the models. So Noah uploaded some really nice STLs that you can use to print your own basketball. So we want to get to, I think that's all you had for the second takeaway, right? We're going to get into the third one here, Noah?
Yep, that's exactly it. Yeah.
Awesome. And I believe the third one, it's involving printing the basketball, how you actually manufactured, how you actually printed the sort of end result basketball that you created, right?
It is. Yeah, this was definitely the most exciting part. but it also required the most patience. So each one of
Okay,
these
tell us more.
pattern parts took around 9 hours to print. I
Mm-hmm.
had 8 of them, plus there was a bunch of pieces for the laces. So in total, it took around 80 hours of printing. I had 2 machines running, so it took 40 hours, so about 2 days to get this first basketball. I used standard FDM machines here. You could get these for a couple $100 nowadays. So for the price of one 3D printed Wilson basketball, you could get like three 3D printers. And the material as well was really accessible. I used standard flexible TPU that you can get off Amazon for around $20. And I chose this specific brand because my Prusa 3D printer already had a profile for it, so I didn't have to tweak it that much. In fact, the only setting I changed was this one I highlighted in red called Avoid Crossing Perimeters. If you've ever printed in TPU before, you know that it can be a very stringy material to print with. It can kind of glob up on itself and leave artifacts on the surface.
Mm-hmm.
So leaving this setting checked on, I found helps with a lot of that, and it leaves a better outer surface finish. But other than that, it was relatively easy to print in. The flexible material also made it easy to assemble because with that interlocking mechanism I showed earlier, those walls could kind of flex in and then snap into place. And while that worked really well and the ball was able to stay together initially, once you tried to bounce it, it wasn't quite as sturdy as I'd hoped. I'll show this first experiment here.
Okay.
You can't hear it on this video, but I'm laughing very hard in the background.
Yeah, that doesn't happen with this basketball that I showed earlier.
No, not typical. Also, shout out to Shreyas, who helped with this awesome simulation.
That looks awesome. That's super detailed.
Yeah,
That's basically showing you like what your eye actually can't see, and I'm sure that the deformity has been scaled up for illustration purposes, but yeah, that's really cool.
yeah. I like my colleague or our colleague Michael Steves actually just pointed out this basketball has a really cool feature where when you bounce it, you get to see the exploded view.
Wow. Yeah,
really appreciate
the CAD community never disappoints.
that.
Shout out to Michael.
But so still though, I wasn't going to give up that easy. You know, my next try was probably the more traditional method, printing this as one part.
Mm-hmm.
So I redesigned it again with X Design, making the solid ball, adding the pattern in X Generative Design. But this time I combined all the pieces. And in order to print this, I did have to go against my initial constraints and add supports. And this took around 70 hours to print. So essentially just as long as it took to print the other basketball in pieces. And the results came out looking better than I expected for the most part. The top especially, I was worried because there was no support underneath that top section.
Mm-hmm.
But it honestly printed pretty fine for the top. It was the bottom part where all of those fears I had about TPU trying to peel that support off the bottom, it came off, you know, kind of gunky on the bottom. I used organic tree supports to print this.
Mm-hmm.
If anyone in the chat knows a better support setting to print TPU, please let me know. On a single extrusion machine, I'm definitely, you know, open to learning more because there was definitely room for improvement on this bottom surface. But overall, it was a success. It printed as one piece. It won't break apart. TPU is a very durable material. And the bounce test was a lot more promising, as we'll see here. So it had some bounce to it.
A lot more promising.
Yeah.
Look at you. You're gonna hit us with the Jamal Crawford double crossover in a second.
I wish. But yeah, so overall, that part was a success. And even though I didn't get the performance I wanted with the first attempt, I was able to accomplish the original goal, which was print a fully airless basketball with no support, no glue required, and have this cool hex pattern. And like you already pointed out, Sean, you know, everyone in the chat, you can do it too. I attached both the 3D printable files into this link. I also included both the STLs and 3D XMLs in case you want to edit them in any type of way. So if you have X Generative Design and you want to make that pattern even cooler, you can do that. And as you mentioned, Sean, if you have any questions on how to print this, on the pattern, on the model, be sure to comment on that post and tag us.
Awesome. Well, Noah, anything to go over? Those are three awesome topics, and I hope everyone in the chat let us know what you thought of the new format. Very concise, at least we aim to be with these three key topics. But anything else you wanted to mention to us before you go?
Yeah, I would definitely just say check out that Made in 3D community where I posted these models. There's a ton of great designers there, like-minded engineers that have a great amount of experience. Actually, as I was doing this project, I reached out through the platform to get some help on X generative design. And it turns out other CATIA people have been trying to replicate this geometry as well. So I'll shout out one particular person on the CATIA team, Vincent Manier. I hope I'm saying his name right. He made some really complex patterns with this ball that include 2-layer lattices, which are actually close to the original design. And he also informed me that the original designer of the Wilson basketball is a CATIA champion.
Oh, wow.
That was pretty cool to hear. And other than that, I'd say, if you like what you saw today and you want to see what else we could do with these cool patterns, let us know in the chat. Comment on that post. I can tease the tennis ball here. We also messed around with
Airless everything.
Airless everything. So if something else you want to see, let us know, and we'll be happy to try it out.
Awesome. Thanks so much, Noah. So you guys heard it many times throughout the episode. Let's continue the conversation. SolidWorks.com/Noah gets you right to that post. You can download the STLs. You can ask Noah questions. Noah will be monitoring that for next 10 days or so, next 2 weeks or so. So if you have any comments, questions, anything like that, if you have your own version you want to show off, feel free to upload it there. So definitely want to shout that out. But hey, before we go, I also wanted to say, last time we were streaming, we showed a lot of 3D Experience World, right? We were there for 3 straight days showcasing the design, manufacturing, simulation, learning, and networking extravaganza that was 3D Experience World. And before we go, today we want to remind you that you can get on a special list. So we have a special list here, and we can show a QR code for that. So the list actually gets you access to information on a rolling basis as it emerges for 3D Experience World 2025, which will be this upcoming February, about a year from now, in the great city of Houston. So once again, any new information as it comes out, new speakers, general session speakers, the call for papers, just stay in the know, as well as any special discounts that may come out for tickets for attendance. So once again, I wanted to give that a shout out just to continue our collective learning as a community. But once again, on behalf of Noah and myself, I wanted to thank Noah, of course. Thank you to our producer, Jesse. And I'm seeing some of you were scanning the QR code. That's an awesome feature of Restream here. And thank you for all of you in the chat for your cool CAD puns and your viewership. Make sure to subscribe, like, and we will see you next month for another episode of SolidWorks Live Design. Take care.
Thanks, everyone.